Every time you flinch while biting into ice cream or sip a scalding cup of coffee, you're not just experiencing modern dental sensitivity. You're feeling the echoes of an evolutionary past that began over 465 million years ago. That sharp jolt in your teeth? It's the whisper of ancient armor. Not metaphorical armor, but real, calcified plates worn by prehistoric fish that once cruised primordial oceans. Armor that felt the world, just as your teeth do now. In a groundbreaking new study, scientists have discovered that our sensitive teeth, the kind that can twinge with the slightest shift in temperature, actually trace their origin to the body armor of long-extinct sea creatures. This stunning evolutionary lineage ties your smile to the ancient sensory surfaces of Earth's earliest animals. This isn't just a story about teeth, it's a revelation about where we come from, about how structures evolved not merely to chew and chomp, but to feel. And it all began hundreds of millions of years before humans ever appeared. Published on May 21, 2025, in the journal Nature, this remarkable research was led by Dr. Yara Haridy, a paleontologist and evolutionary biologist at the University of Chicago. Alongside an international team of collaborators, Dr. Haridy's study peels back deep layers of evolutionary history to uncover how a structure designed for external sensation gradually became the sensitive dental tissue we all possess today. The researchers began with a big question: what is the earliest evidence of vertebrate life? To find the answer, they turned to fossils from the Cambrian and Ordovician periods, stretching from 541 to 443 million years ago. These epochs were a time of radical innovation in evolution, the birth of new body plans, hard skeletons, and the earliest complex nervous systems. One of the key markers of a vertebrate is the presence of dentine, a dense calcified tissue found just beneath the enamel of human teeth. In modern vertebrates, dentine plays a structural and sensory role, housing microscopic tubules that connect to nerves. If researchers could find dentine in ancient fossils, it would help pinpoint when and where vertebrates first emerged. Enter Anatolepis heintzi, a puzzling species long thought to be one of the earliest jawless fish. Its bony, scale-like armor had intrigued paleontologists for decades. Was this creature a true vertebrate ancestor? Did it possess dentine? Using cutting-edge high-resolution CT scanning technology, Dr. Haridy and her team closely examined fossilized specimens of A. heintzi. What they initially found was promising: tiny pores in the armor that seemed to contain a mineralized material consistent with dentine. It was a potential breakthrough. If those pores were lined with dentine, it would suggest that A. heintzi was indeed an early vertebrate, perhaps one of the first. But science thrives on skepticism. The team knew they had to look deeper. So they compared A. heintzi's features with a wide range of both ancient and modern species, from prehistoric fossils to today's marine animals like crabs and lobsters. And that's when things got truly surprising. Those so-called dentine pores, they weren't behaving like the internal dental structures of vertebrates. Instead, they resembled external sensory organs, more like the mechanoreceptors and chemoreceptors found on the hard shells of arthropods, such as crustaceans. This reanalysis led the team to a shocking conclusion. Anatolepis heintzi wasn't a vertebrate fish at all. It was an ancient invertebrate arthropod. That one classification change unraveled decades of assumption, but in its place, it offered a far more profound insight. Here was the twist. Even though A. heintzi was not a vertebrate, it had evolved mineralized sensory tissue, remarkably similar to the early dentine found in vertebrates. Two vastly different lineages, arthropods and vertebrates, were using the same biological approach for very different organisms. That kind of biological repetition is known as convergent evolution, where nature independently finds similar solutions to life's challenges across unrelated species. But more than just structural similarity, the study suggested something deeper: a shared genetic heritage. What Dr. Haridy and her team propose is that both lineages, the arthropods and the vertebrates, inherited a common genetic toolkit for producing mineralized sensory tissue. This toolkit was used in ancient exoskeletons to build armor that didn't just protect, but allowed organisms to feel the world around them. And eventually, in vertebrates, that same toolkit was redeployed, not on the outside of the body, but inside the mouth. From armor to incisors, from sensing the flow of water in the open sea, to sensing the chill of a popsicle on your teeth. Over hundreds of millions of years, that mineralized sensory armor was internalized and refined into the dentine that forms the foundation of human teeth. And remarkably, that ancient sensitivity remained intact. This shows us that teeth can also be sensory even when they're not in the mouth, Dr. Haridy explained in a statement accompanying the research. The study revealed that sensory structures had already evolved on exoskeletons by at least 460 million years ago, long before vertebrates emerged with the kind of skeletons we're familiar with today. And through the lens of evolution, the sensitivity of modern teeth becomes far less mysterious and far more poetic. Viewed through this evolutionary lens, the researchers wrote in Nature, the fact that teeth in the mouth are extremely sensitive is less of a mystery and more a reflection of their evolutionary origins within the sensory armor of early vertebrates. This discovery isn't just a fascinating footnote in evolutionary biology. It changes how we understand the human body. We often think of teeth as utilitarian tools, hard white instruments for breaking down food. But they're also complex sensory organs loaded with nerves, evolved from ancient systems designed for environmental awareness. Our teeth are a story of survival, adaptation, and reinvention, a biological success story written in calcium and nerve tissue. And they're not alone. Many parts of the human body are evolutionary tapestries woven from ancient threads. But the journey of our teeth, from armor plates on invertebrate sea creatures to ultra-sensitive oral sensors, is one of the most compelling. It reminds us that evolution isn't a straight line. It loops, recycles, and reuses what works. The structures that once helped fish detect predators are now what help you avoid biting into soup that's too hot. So the next time your teeth ache or zing from something too cold, don't curse your dentist just yet. Instead, pause and marvel, because that pain is a time capsule, a window into a world where creatures felt the currents through armored skin, and where your most personal sense, that of taste and temperature, had its humble beginnings in the armor of ancient sea life. If you want more stories that explore the strange and wondrous links between the past and the present, between fossil and flesh, hit that subscribe button and join us for more journeys through deep time. Because in evolution, the past is never really gone. It's right there in your bones, and even closer in your teeth.